Okay, I want to take a look at an example and follow up on what you're showing in the video that's included in my math lab. And this is an example that there was not an example quite like this in the video. We're going to use long division to do this division problem. So x plus 2 goes here, and then the divisor is x cubed plus 0x squared minus 7x minus 6. You want to make sure that you put in an x squared term if it's missing. And then this is kind of the way I like to look at this. I look at the first term and the first term, and I think about, if I take x cubed and divide it by x, what do I get? X squared. And this tells me what I'm going to put on top up here. And then I think about multiplying x squared by the entire quantity x plus 2. So x squared times x is x cubed. X squared times 2 is 2x squared. And then we need to subtract the x cubed plus 2x from the two terms that are directly above it. To do that subtraction, I would recommend that you think about just changing the signs and adding. It's easier to do it that way. So 0x squared minus 2x squared is negative 2x squared. X cubed minus x cubed is 0. Bring down the next term. And you don't necessarily have to draw that little arrow if you don't need to. And now what I'm doing is I'm looking at negative 2x squared, and think about dividing it by x. So negative 2x squared divided by x would be minus 2x, and that is what gets written on the top. Distribute negative 2x into x plus 2. Change your signs and add. Negative 7 plus 4 would be negative 3x. Minus 2x squared plus 2x squared is 0. Bring down the minus 6. And now I'm looking at negative 3x divided by x, which would be minus 3. That's the next thing that gets written on the top. Negative 3 times x. Negative 3 times 2. And subtract. And we've got actually 0 this time. So this number, of course, is the remainder. And this polynomial is the quotient. Now, we're going to work the same problem, but using synthetic division. So our problem was x cubed minus 7x minus 6 divided by x plus 2. Synthetic division only works if you're dividing by a linear quantity, x plus 2, x minus 6, something like that. Take the opposite sign. So if there's a plus 2 right here, then in our problem we're going to set up with a minus 2 in the box. And then the coefficients of each of your terms. 1, 0 for the x squared coefficient, minus 7, minus 6. Leave a space and draw your line. Now, you're going to bring the first term straight down, multiply by negative 2, add. Take this number, negative 2, multiply by the minus 2 that's here, add. Negative 2 times negative 3 is 6, add. This number is always the remainder. And these numbers are the coefficients of the quotient. Now we started with an x cubed function, so our quotient is going to be x squared minus 2x minus 3. Okay, now one other thing I want to do with this same problem. Think about if we write this function f of x, x cubed minus 7x minus 6. If I ask you to find f of negative 2, of course you know you're going to plug in negative 2 for x, negative 8 plus 14 minus 6, and when you add, you get 0, which was the remainder. That's always going to happen. In fact, there's a theorem called the remainder theorem that kind of outlines this. If you have a polynomial function f of x and you divide by a linear quantity x minus some number, the remainder is f of c. In other words, the remainder from the division problem is what you'd get if you plugged in c into the function, or if you substituted c into the function. So sometimes synthetic division is called synthetic substitution because it's just another way of looking at the same thing. Now, if we go further with that, since the remainder, when our function was x cubed minus 7x minus 6, and we divided that by x plus 2, f of negative 2 equals 0 is the remainder. We can take that one step further and think about what does it mean when we get a remainder of 0. For instance, if I have 3 and I divide that into 6, 3 divides into 6 2 times, 2 times 3 is 6, the remainder is 0. So 3 divides evenly into 6. In other words, 3 times 2 equals 6. So 3 and 2 are the factors. So basically, the factor theorem says that when you have the remainder as 0, that means you've got a factor of your function, of your polynomial. So we can be a little more specific in saying if you've got a value c that when you plug it in you get 0, that tells you x minus that number c is a factor. And it can go the other direction too. If you know that x minus c is a factor, then you can conclude that if you plug in that number c in the function, you will get 0.